All right, so today's lesson, we're looking at topic 2. Topic 2 will be divided into 2 sections because it is a very long topic. So today we're going to look at topic 2, mixing and dissolving, but specifically we're going to look at mixtures and pure substances and how matter is organized. So when we talk about a pure substance, it contains only one type of particle. It can still exist in 3 states of matter, solid, liquid, or gas. Elements are examples of pure substances. So elements are found in the periodic table. So anything in the periodic table that we see there as elements, those are pure substances. So any examples from the periodic table such as iron, gold, oxygen, sulfur, carbon, those are all pure substances. Then we have chemical compounds. These can be when you take elements and put them together, then they become compounds. So for example, water is a compound. It's made of H2O, so 2 hydrogens and 1 oxygen. That is a chemical compound. Salt is another compound. Salt is made of sodium chloride, sodium and chlorine together makes salt. And then sugar, there's different types of sugar, which is also a chemical compound. And when we talk about physical properties, these are characteristics that describe matter. So physical properties like color, odor, hardness, things like that. Then we get into mixtures. A mixture is going to contain 2 or more pure substances. Each substance keeps its properties, but it may be difficult to identify these properties. So for example, there's sugar in soda. So that sugar in soda, it's still going to keep its properties, but because it's it's dissolved together, it's harder to identify each substance. Sometimes it may be easy to identify the different substances in the mixtures. For example, if you have a bag of mixed vegetables, you can clearly see the different vegetables in the bag. All right, so mixtures can be homogeneous or heterogeneous. And we'll go over those terms pretty quickly here. So this is the classification of matter. So up top we have matter, all matter. So it occupies space, it possesses mass, it exists as a solid, liquid, or gas. Then it breaks up into a pure substance or a mixture. So recall, a pure substance can be an element or a compound, like we talked about, an element like hydrogen, a compound like water, which contains hydrogen and oxygen. Then we get into mixtures. This is where we have 2 or more pure substances, but they can still be separated by physical methods. So homogeneous, these are mixtures that have a uniform composition and properties throughout the whole substance. You will also hear it being called a solution. And then heterogeneous, the mixture is not uniform, so its composition and properties are separate. So here, homogeneous mixtures, they appear to be one substance. The particles of different substances are very intermingled together. Examples are vinegar. Vinegar is made up of water and acetic acid. Clean air is a mixture of lots of different gases. So in a homogeneous mixture, the materials are blended so thoroughly that every sample of the mixture will contain equal amounts of all matter that make it up. Okay, so every part of the mixture is the same. They are also called solutions. So it's a homogeneous mixture of 2 or more pure substances. So think of a solution of water and sugar. That would be a homogeneous mixture. Okay, so what happens is particles of each component, they slip in between each other and they form this even distribution throughout the entire mixture. And then a heterogeneous mixture, it contains 2 or more materials, but they are still visible. So they're made up of parts. They're also called mechanical mixtures. And 2 or more parts can be seen. Different kinds of particles, they stay together. So examples of heterogeneous mixtures, Soil, you could see different parts in soil. Blood, you could see the different parts in blood. Then concrete's another example. All right, so just another chart here showing classification of matter. So matter is split into pure substance and mixtures. Pure substances are elements and compounds, and then mixtures are either heterogeneous or homogeneous. There are in-between mixtures. So the first one we're going to talk about is called a suspension. So sometimes it can be difficult to determine if a mixture is homogeneous or heterogeneous. A suspension, it is a heterogeneous mixture. The particles will settle slowly after mixing. So you can mix them up together. It kind of looks like one substance, but if you let it settle, if you let it just sit, eventually the particles will settle after mixing. So examples are like tomato juice, Italian dressing, orange juice, even sometimes the natural fruit sediment will settle. And then these suspended particles, they're large enough to be trapped by most filter papers or filters. Another heterogeneous mixture is called a colloid. A colloid, it's still a heterogeneous mixture, but the particles do not settle. An example is milk. The process of homogenization, it helps the fat globules in milk stay dispersed longer than suspended particles. And then this homogenization process will also take those fat globules in milk and make them extremely small, and then distribute it uniformly throughout the substance. So when it's properly homogenized, the cream will not rise up to the top. And then these colloidal particles, they are small enough to pass through most common filters. There's another in-between mixtures called emulsion. So this is a mixture in which droplets of fat are prevented from joining together by an emulsifying agent. An example like mayonnaise. So an emulsifying agent is used. It's usually a protein that will prevent the tiny droplets of fat from joining together. So mechanical mixtures are again heterogeneous mixtures. They are obviously heterogeneous. You can see the separate parts. And those separate parts are called phases. So here we have oil and water together. So the oil will separate from the water, and you can see the two different phases. This example here is the bubbles in soda. So the bubbles make up like the gaseous phase, and then the liquid part makes up the other phase. All right, so we're going to pause here.
The world we live in is made of things. Billions and billions of different things, like pickles and pianos, and dump trucks and octopi. And even though these things seem totally different, they're all made of the same stuff, just combined in different ways. To give you an idea of how this combining works, let's take something apart. Let's start with this bowl of macaroni salad. If you were to reverse a recipe for macaroni salad, you'll see it's made by mixing together a bunch of ingredients, like macaroni, mayo, vinegar, vegetables, and mustard. This type of combining is called a mixture. When you make a mixture, you're combining two or more things together without actually changing the chemical identity of those things. Like mud, for example. The soil and water in mud haven't actually changed. They're still soil and water. You've just created a mixture of soil and water. Mud. It turns out that macaroni salad is actually a mixture of mixtures, because many of the ingredients, like mayo and mustard, are already mixtures themselves, which is nice for us because if we look closely, we'll see the three main types of mixtures that exist. The size of the particles in a mixture determines the type of mixture. On one end of the scale is a suspension, like our muddy water example. You get this if you take big chunks of something and mix it with something else, so those chunks are just floating around. Take runny mustard, for example. You'll see a bunch of little particles like mustard seeds, pepper, allspice, and minced shallots all floating around in a liquid, in this case, vinegar and water. This is called a suspension because you've got particles of one thing suspended in another. Now, on the other end of the spectrum is a solution. The particles in this mixture are so small, they are the actual molecules. A solution is sort of like a suspension of molecules, where one type of molecule is blended or dissolved with another. Vinegar is an example of a solution where the molecules of acetic acid are blended with molecules of water. The chemical properties of the molecules haven't changed, they're just evenly mixed together now. Salt water and carbonated soda are both examples of solutions where other molecules are dissolved in water. The last type of mixture is called a colloid, which is somewhere between a suspension and a solution. It's when you take two materials that don't dissolve and you make the particles so small that they can't separate. Mayo is what happens when you take oil and water, which don't mix, and you bind them together, usually with the help of another substance called an emulsifier. In the case of mayo, it's lecithin found in eggs. And now you're left with really small globs of oil hanging out with really small droplets of water. Whipped cream, hairspray, styrofoam, and Jell-O are all other examples of colloids. So, let's get back to macaroni salad. You've got colloids like mayo, suspensions like mustard, and solutions like vinegar. But you've also got celery, shallots, and all other vegetable chunks that are also part of the salad. These aren't mixtures really, but we can break them up. Just like a TV can be broken up into smaller and smaller complex component parts. In the case of vegetables, if you keep breaking things up, you'll eventually end with thousands of complex organic molecules. Things like ATP synthase, and RNA transcriptase, and water. So now, once we've unblended all the solutions, unmixed all the colloids, separated all the suspensions, and taken apart all of our vegetables, we've reached the end of what we can unmix physically. What we're left with is a whole bunch of molecules, and these molecules remain chemically the same, whether they are by themselves or thrown together in a salad. If you want to separate these guys even further, we need to unmix things chemically, which means we need to start breaking some bonds.
Summertime is picnic time with sweet iced tea and yummy fruit salad. And ants. But still, yummy fruit salad. And hey, did you notice something? Those foods have something in common. They're both mixtures. Things made by combining two or more different things. Not the ants. They're just ants. But the iced tea and the fruit salad are mixtures. Anytime you combine two different things, you make a mixture. Whether it's strawberries and bananas, raspberries and blackberries, or cantaloupe and Legos. Which I don't recommend eating at all. I'm just saying it's a mixture. So let's have a little science with our picnic, shall we? Let's talk about the different kinds of mixtures we can discover. For example, if we mix sand and water in a glass, we'll get a mixture, even though after a while the sand will settle to the bottom of the glass. But if we stir some sugar into the water, the sugar looks like it disappears. But it really doesn't. The particles that make up sugar become distributed or spread around evenly among the particles that make up water. We call this kind of mixture a solution. Solutions have two main parts, the solute, which is the stuff that dissolves, in this case the sugar, and the solvent, which is the stuff in which the solute dissolves, in this case the water. Now, solutions can be made from types of matter that are in different states too. For example, the air that we breathe is made up of a solution of gases, mostly nitrogen, oxygen, and carbon dioxide. And soda water is really a solution of carbon dioxide gas and liquid water. But no matter what, and this is important, mixing things together in solutions does not make a whole new substance. Solutions can be separated again, back into the substances that made them. So, for example, if you leave the lid off a bottle of soda water, the carbon dioxide that's dissolved in the water will slowly float up to the top and bubble away. Given enough time, you'll be back to having plain old water in the bottle and carbon dioxide in the air as two separate things, not mixed together. So when you take a sip of your favorite fizzy drink, you're drinking a solution. But not all substances dissolve easily into other substances. The ability of something to be dissolved is called its solubility. Sand doesn't dissolve in water, for instance, so we say it has low solubility in water. But sugar dissolves pretty easily, so sugar has high solubility in water. Still, no matter how easily something might dissolve into another thing, you'll eventually reach the point where it can't dissolve anymore. Let's say you pour a whole bunch of sugar into a small glass of water. If you keep adding sugar to it to make it even sweeter, and who would blame you for trying, you'll get to a point where no more sugar can dissolve. The extra will just sit at the bottom. This is called saturation, the point at which no more solute can dissolve into a solution. Saturation happens when there's just no more room for the particles that make up the solute, in this case the sugar, to squeeze between the particles of the solvent, the water. Whew! All of this is making me snacky. Let's check out our picnic table again and investigate the different kinds of mixtures we see there. Let's start with the fruit salad. That's definitely a mixture of different kinds of fruit. Is it a solution? Nope, because the particles that make it up aren't equally distributed. I can dip my spoon in there and come up with nothing but strawberries one time, and then go back for more and get a spoonful of only bananas. How about the sweet tea? The solution to that question is that it's a solution. Particles of, say, water and sugar in the tea are evenly distributed in the glass. Every bit contains water and sugar. They're spread out evenly. Now, can the substances that make up our iced tea solution be taken apart again? Yep, if we heat the tea so that the water in the solution changes from a liquid to a gas, it evaporates into the air, leaving the sugar behind. So let's go over what we learned at our little mixed up picnic. A mixture is made by combining two or more substances. When the particles that make up the substances are equally distributed, the mixture is called a solution. Solutions can be made of substances that are in the same state of matter, like gases in the air, or in different states of matter, like the gas bubbles in soda. The solute is the part of the solution that is dissolved, and the solvent is the part into which the solute dissolves. And solutions and some other kinds of mixtures don't always make new substances, even though it might look that way. Now, let's enjoy what's left of our picnic before the ants carry it all away.